we're specifically going over solving equations in the form of absolute value of something equals the absolute value of something else. Okay, so specifically that's what we're looking at. Basically, absolute value on both sides of the equal sign. Okay, so this is kind of different, something that we haven't seen before, so I wanted to go over it. But if you see this, then your answer is going to look like, bless you, your answer is going to look like the positive forms of both of those equaling each other, and then the positive and negative. So it'll be x equals negative y. Okay, so it'll look like both of those. You'll see two separate problems still, like you normally would.
Just the answer would be negative and positive.
Well, we're going to do an example, and we'll see if that still answers your question. If it doesn't, ask it again, okay? So let's do some examples. Let's start with example 12 from the book. It says the absolute value of z plus 3, close absolute value, equals the absolute value of 2z minus 7. Close the absolute value. Okay, so this is our problem. What we have to do is separate it just like we would before. This is going to be this or that. So it's them both just the way they are. So z plus 3 equals 2z minus 7. When we see these, we just solve it like normal. Okay, so we would simply put all of our z's on one side and all of our other stuff on the other. So I'm going to move the 7 first. I'm going to add 7 to both sides. I get z plus 10 equals 2z. And obviously I'm going to move my z to the other side. Okay, and that leaves me with z equaling 10. So this is one of my solutions. Now remember, it's an or, so it's this or another solution. It'll be this or another solution. Okay, and the other side will be set up basically the same way. So I'm going to write down the same thing. Z plus 3 equals, and then I'm going to write 2z. I leave a little space for a reason, okay, so make sure you include that space. So it's the same thing. So when I look up here, I said I'm going to have both of them positive and then positive, negative. So this one's positive and negative. I just give a negative to everything on that right-hand side. Okay? Everything on that right-hand side. And then I solve it. So nothing's going to happen with anything on the left side because I can't do anything with it yet until I distribute this negative. So negative 2z plus 7. Okay, and then I solve it normal again. Okay, I'm going to add 2z. Okay, that goes away. I have 3z plus 3 equals 7. I'm going to subtract 3. You get 3z equals 4. Divide by 3. And my final answer is z equals 4/3. So my solution is, let me just drag it down, z equals 10 or z equals 4/3. Okay, so those are my two answers. It's not a big difference in what we do after we set it up. So the real main thing that you need to take away from this is the original setup of it, so that you don't end up doing 5 or 6 problems. Okay, do 2. To write this as a set, I think in your my math lab stuff, it'll give you the set and say, what is the solution set for this problem? And you'll say 10 and 4/3. Okay, so this is just the set of numbers 10 and 4/3. Okay, these are just sets, right? This is not interval notation. Don't get that confused. Not interval notation at all.
Okay, so whenever at the top when you put x equals negative y, you just meant one column would be all positive,
right,
and the other would be negative.
The opposite of the right side. So it's the same. All you do is drop the absolute values, and then on the second one you make the right side all negative, or all opposite. Think of it as opposite, because if it's already negative, it'll turn positive. Okay, any questions there before we do an example out of the book? Alright, then let's do an example out of the book. Flip to page 130. And I will let you pick, give you about 10 seconds to see which one you want to do. 63 through 70 is where you're going to find them. Okay, I heard 64. Let's do 64. And we can do 66 too. You want to do 64 still? Or just 66?
No.
Just 66. Okay. 66 gives us this problem. 3r. So I'm going to write this instead of 3r over 4, I'm going to write it as 3/4 r. Okay, it's easier to read for me. If you don't like it, you can write it the way that you have it, but it's up to you. Plus 1/8 in absolute values. Then it is equal to 1/2 r minus 3/8. Okay. So again, we set this up in two problems. The regular one, 3/4 r plus 1/8. The way it just drops the absolute value, and 1/2 r minus 3/8. And then I would solve. Okay, I'm going to set up the other one right now, though. The left side stays the way it was on that first setup, so 3/4 r plus 1/8. And then on the right side, we put a negative, and I'm going to open a parenthesis. 1/2 r minus 3/8. Some of you probably want to convert this to a decimal. That's okay, as long as it is an exact decimal. Okay. It is for me, too. If I can get my pencil to work, we will continue. Alright, here we go. I'm going to solve this one on the left first. So, again, I need all of my r's on the same side and all my regular stuff on the other side. So, I'm going to subtract my 1/2 r because it's my smaller number. 1/2 r minus 1/2 r. I will show you those who struggle with this in graphing calculators. Show you how it works, okay? Remember that the last name is going to stay the same, so I'm just going to drag down my r. I'm not going to try to put that in the calculator. That would be ridiculous, okay? I just look at the coefficient for it. So I have 3/4, and I'm going to put it in parentheses. So 3/4 in parentheses minus 1/2. I'm going to put that in parentheses as well. So it just looks like that when I'm all said and done. Parentheses inside of each one of those. Okay, press enter. If I want it in fraction form, which I do in this case, I just tell it to put it in fraction form. Okay, math, fraction, enter, enter. Okay, so it's 1/4. If you found a common denominator, you would have got the same exact answer, so it's no big deal. So 1/4 r plus 1/8 equals negative 3/8. Now again, I want to move all my other numbers to the other side, so minus 1/8, minus 1/8. I'm left with 1/4 r equaling, and again, I'm going to show you how to do this one more time. See if I can get that glare off of there. It's negative 3/8, so negative 3/8 minus 1/8, minus 1/8. Enter. It gives me a negative 1/2. If you don't know that 0.5 is 1/2, you can press math, fraction, fraction, negative 1/2. Okay? Negative 1/2. Now here's the part that people get really confused on, but in reality we're doing the exact same thing. If we're multiplying by 1/4, what are we going to do to get rid of a multiply by 1/4? Divide by 1/4, right? Or multiply by 4 is what Taylor's telling us to do, which is, in her opinion, a lot easier, and I agree. But if I wanted to do this on my calculator and make my life harder because I hate fractions that much, I would take negative 1/2, type it in my calculator inside parentheses, and I would divide it by 1/4. Press enter, I get negative 2. Okay? So r in this case would be negative 2. Or whatever I get on this right hand side. Okay? So the left stays the same, 3/4 r plus 1/8 equals, I distribute that negative. I get negative 1/2 r now, plus a 3/8. Okay, I'm going to add this 1/2 r. Add this 1/2 r to both sides. Again, if I don't know how to do this, I can go ahead and type it into my calculator. But if I do know how to do this, find the common denominator, put the 2, change that to a 4, right? We get 5/4 r plus 1/8 equals the 3/8. Subtract 1/8. 1/4. Why did I change that? No. Okay, sorry. On the left side, I thought I had something different. So subtract 1/8 from both sides. It's gone. I'm left with 5/4 r on the left equals to 2/8, which is 1/4.
That's what I thought you were on.
Okay, and I get rid of a multiply by 5/4 by dividing by 5/4, and I get 1/5. Get rid of a multiplying 5/4, or sorry, I get rid of a multiplying 5/4 by dividing by 5/4. So I take 1/4 divided by 5/4. Why did it do that already? Wouldn't be the first time I was wrong, but 1/5. Good. Any questions about calculator work? Any questions about literal work? Waiting? Andrew? Yes, I got 1/5. Kaylee, you got a question? 68, sure. Tell me where we're at. 1/5, right here. This is our total answer. So the solution set. Remember, when you divide fractions, you multiply by the reciprocal. So if you're not doing it in your calculator, okay, then you probably did something wrong in your calculator. Come show me. Whoops.
Oh, maybe I did it.
Yes, yeah.
Is it just do 1/4 divided by 5/4?
It is, yes.
That's what I did wrong.
Okay. 68, I was requested to do 68, so if you don't need 68, that's fine, but please remain quiet for you, the rest of your classmates. We get 2x over 3. I'll leave this one with the x on top instead of moving it to the side for those of you who don't want me to change it. Okay, so that's in absolute values. 68. 7/8 minus 2/3 x. Okay, I think I know why you wanted me to do this one.
I just wanted to do it for another example.
Oh, well, never mind then. You're going to be pleasantly or unpleasantly surprised when we get to the end.
Wait a second. Almost the same.
Okay, so I rewrote it without the absolute values. I'm going to start to solve. You should notice something immediately as I start to do this. I'm going to add 2x over 3 to both sides, which is nice because it already has a common denominator. So I end up with 4x over 3 on the left-hand side minus 7/8 equaling 7/8. I'm going to add 7/8 to both sides. Okay, so I still have 4x over 3 equaling to 14 over 8, or I could reduce it. Depends on if you want to do all your reducing at one time or do it as you go. Okay, I do it at the end. Unless I'm using a calculator, then I just let the calculator do the work for me. So in order to get rid of a multiply by 4/3, I would divide by 4/3, which is the same as multiplying by 3/4. Okay, so I'm left with x equaling, and then I will find out whatever that is equal to. So in my opinion, it might be easier for you to go ahead and use your calculator. If not, I would reduce them before I'd move on. Okay, so reduce that one down to 2, reduce this one to 7. I'd get 21 over 16. Can I reduce it anymore?
No.
Negative. Okay. 21 over 16. Then it is set in stone. That is one answer. I need to do my second piece. So I'm going to have to combine that just a little bit better than I did this time. I have 2x over 3 still, minus 7/8. This is going to be equal to the negative of this. So I'm going to go ahead and distribute out my negative and write it down just one time. So it's negative 7/8 plus 2/3 x. I went ahead and distributed my negative as if I had a negative out here and I gave it to each piece. Okay? Yes. So on this one, I'm going to add 7/8 to both sides. My 7/8 go away on both of them. So I'm left with 2x over 3 on both sides. Now I can subtract 2x over 3 if I wanted to, or I could just notice that this is something that is true. Okay? But if you wanted to go ahead and do that, go for it. I don't mind. This is kind of the way I taught you originally. So you get 0 equals 0. What does that tell you? Infinitely many solutions, right? So it is either 21/16 or infinitely many solutions. Which one do we write as our final answer? Infinitely many. in the context of this problem, what is the solution set? We say that the solution set, since it's x's, is x such that x is what? If it's infinitely many solutions, it's all of the what? Real numbers. So x is an element of the reals.
Right, so if the answer ends up being infinitely many solutions, then that's all that we write. We don't write the r, or the x is infinitely over 16.
No, because that's included in the infinitely many solution
So
subset.
then if it's no solutions, we just write no solutions.
No solutions, yeah. If you got one that was not true at the end, then you would literally write no solution. Okay? There is no real solution.